Bisectors, medians, and altitudes on triangles. This lesson is a lesson on vocabulary and uses of these points on a triangle. Not a lot of actual math calculations, but a lot of vocabulary you need to focus on. Basically, we're going to be trying to find the center of the triangle today, and I'm going to tell you that there are actually 4 centers to a triangle. It depends on what center we're talking about. First, we can find a center by using what are called perpendicular bisectors of a triangle. In other words, we take a perpendicular bisector, or a line that cuts another line in half and is perpendicular to it. So we've got line AB down here at the bottom. It's going to be cut in half by CD, and they meet at a 90-degree angle. That's important. So 90-degree angle, and it's cut in half. That's a perpendicular bisector. And what's interesting is if we take the 3 perpendicular bisectors of a triangle, one for each of the 3 sides, they will meet at a center point of the triangle. So here we have triangle ABC. If we put in the perpendicular bisectors, notice we cut the bottom in half, the side in half, and the other side in half. The 3 perpendicular bisectors will meet at a point in the center of the triangle. That center point is what we call the circumcenter. The circumcenter is the center of the smallest circle that can go around the vertices of the triangle. We can't make a smaller circle that goes around this triangle. What that also tells us, though, is that that center point is equidistant from each of the vertices, from A, B, and C. It's equidistant, the same distance from each corner. Perpendicular bisectors give us the circumcenter. Another type of center can be found using what we call an angle bisector. So instead of bisecting a side, now we're going to bisect an angle. This is where we draw a ray in that's going to cut this blue angle into 2 equal pieces. They are congruent and equal to each other. The 3 angle bisectors from a triangle, as you might expect, meet at a center point in the triangle. So notice in this triangle, we've cut each of the angles in half, and they all meet at this nice center point of the triangle. That center point is called the end center. The end center is the center of the largest circle that can fit inside the triangle. The circumcenter went outside, the end center goes inside the triangle. This point, the end center, is equidistant from each side of the triangle. So if I went out to the sides of the triangle this time, the sides of the triangle, it would be equidistant from all of those points, right in the center. So first we saw the center from all of the vertices. That's the circumcenter. Now we've seen the center from all the sides. That's the end center. 2 different centers. The third center comes from what we call a median. Now a median says, let's find the halfway point of a line of one side of the triangle, and then we're just going to connect it to the opposite vertex. So we don't care about being a perpendicular this time. We're going to go to the vertex instead. So when we go to the vertex, that's called a median. And as you might expect, the 3 medians of a triangle will meet in a center point of the triangle. So if I have a triangle and we cut each of the sides in half and connect those midpoints to the opposite side of the triangle, they meet in this center point. This center point is called the centroid. The centroid is interesting because it's the balance point of the triangle. If you cut this triangle out and took a pencil tip and put the centroid right on top of the pencil tip, it would balance perfectly and not fall off. So we've got 3 centers so far. Center from the vertices, that's the circumcenter. Center from the edge, that's the end center. Center in terms of balance, that's the centroid. 3 different centers. One interesting thing about the centroid, we're just going to add in here, so we're doing a little bit of math. The centroid is always 2/3 of the distance between the vertex and the opposite side's midpoint. In other words, if one part of the line is 6, the other part of the line is half of that, 3. If one part of the line is 10, the other part of the line is half of that, 5. If one part of the line is 12, the other part of the line is half of that, 6. Not really to scale, but that's what we mean by it's 2/3 of the way. 2/3 on one side, 1/3 on the other side. I said there were 4 centers. The 4th center comes from the altitudes of a triangle. An altitude is a line that connects the vertex to the opposite side, and it's perpendicular. We had a perpendicular bisector at the beginning. That cut it in half and was perpendicular. This time we're not going to cut it in half. This time we're going to connect to the top point. Still be perpendicular. And as you might expect, the 3 altitudes of a triangle meet in a center point. So here's a triangle with the 3 altitudes, and sure enough, they meet in a center point, and that center point is called the orthocenter. Now we've got 4 different centers. It's important to note that these 4 different centers might sound similar, but they are usually not the same point in the triangle. They're at different points in the triangle. The center of balance, the center from the vertices, the center from the sides, and then the orthocenter from the perpendicular bisector, or the perpendicular altitudes. What's interesting, though, is if we draw the perpendicular altitudes, and we draw the medians, and we draw the perpendicular bisectors, that will give us the orthocenter, the centroid, and the circumcenter, and all 3 of them fall in a straight line. This was discovered by the great mathematician Euler. Euler is spelled E-U-L-E-R. Euler noticed these 3 points fell on the same line, and he actually found a 4th point related to the triangle that we're not going to talk about today. So this line actually contains 4 points for every triangle. Interesting little tidbit. But for now, what I want you to do is take a look at the homework assignment, working with this vocabulary here. What's a bisector, angle bisector, and a perpendicular bisector? What's a median, and what's an altitude? And the 4 centers that are found from each of these different types of ways to cut up the triangle. It's all vocabulary today, so take a look at your homework and let your instructor know if you have any questions.